Thank you very much, Chiara. As she said, I am a backend developer working in ATT, and amongst other projects, I took care of the Jupyter Notebooks for Ocean Ice. And I've developed most of them, but it's a joint work with other colleagues. And I want to start this presentation by giving you a general overview of infrastructure that I decided to build to share these notebooks. So I'll get hands-on right now. It's what you're seeing now on my shared screen is a static website, and it looks like a normal site, but it's actually in the background. These are all Jupyter notebooks. So each chapter is a Jupyter notebook, and the first is an introductory chapter, just pure MD format, Markdown. I'll get into depth a little bit more later about this. And this is a practical way to share the content of the Jupyter notebooks. As you can see, some of you may already have experience about Jupyter notebooks. There is the code presented in here, but it's not executable. That's why I said it's static. The website, I'll try to give the bigger picture now, is built automatically from this GitHub repository. I have created two different workflows using a service given for free by GitHub called GitHub Actions. And this is a way to give the possibility to also other contributors to the repository to update the website automatically. So I structured this repository in two main branches, the test branch and the main branch. And I'll give some basic information also about Git. When we work on our code, in this case on the Jupyter Notebooks locally, we can then share the state of the code at a point in time with a commit. And we can send it to GitHub, to this GitHub repository, send it to one of these two branches. When a commit is received on the test branch, it will trigger one of these two workflows. And the first, triggered by the commit push to the test branch, will initialize this pipeline that will deploy on another service offered by GitHub, that is GitHub Pages. So in this is a first deploy, just used to check that everything is working fine in the deployment process. After we have done this, we can merge the commit from the test branch into the main branch. But as the name says, it's the most important one where we want to keep everything that's working. So as soon as a pull request is accepted on this main branch, it will trigger the second workflow that will deploy our notebooks that are contained in this folder. I'll show you. Each chapter contains a Jupyter Notebook file. This pipeline will populate this site with updated code of the notebooks. This is just to know what's happening behind what you're seeing. I'll now start to get a little bit more in depth. So what is a Jupyter Notebook? Some of you may already know this, but I'll try to keep everything clear for everyone. So it is a file format that allows us to write in two different type of text. The first is the Markdown format. That is the one you're seeing here. It's all the pure text format. So we have some options to improve the styling, for example, by inserting links or titles, lists, tables, etc. And other kind of text we can write is a Python code. That is what you're seeing here. And one of the benefits of the Jupyter Notebook format is that we can easily share our code and with a very clear and prettily formatted description of what's happening in the code. And another good thing from the code point of view is that in the Jupyter Notebooks, we separate the code into cells. This makes it easy to split the logic of what's happening in the code, and also while developing for debugging, spotting what's happening in each part of the code that we are writing. Now I'll get a little bit more in depth. So the first chapter you're seeing here explains how to interact from a Jupyter Notebook, from the Python code to the ERDDAP web server. This is this is the welcome page of the Ocean Eyes ERDDAP that we have put up. And in this section, you can have the general information. I'll just give you a brief overview. It's the benefits of using ERDDAP are that it makes allows us to have a structured format for every data set. And that's perfect for the integration with Python because we have always the same ways to query the data to gather it. From here, we can access the list of the datasets available. At this time, we have all this. And the first, it's a dataset created automatically by ERDDAP, and it's just a list of all the datasets available. I am telling you this because it's exactly what's happening in the first part of our Jupyter Notebook. Okay, for every chapter, I inserted at the top the link to the Google Colab. Google Colab is a platform that allows us to execute the code on machines hosted by Google. So we can, even if we have a computer that doesn't perform too well, we can access these machines offered by Google and execute our code without any problems. And this is not the case, but it's also possible to use GPU for intensive processes. For example, it's very popular with machine learning. And now we start to execute our code. As you can see, this is the first introductory text in Markdown format. And then we can execute each single code cell by pressing the button here. So for every Jupyter Notebook, in the first cells, I install the libraries that needs to be installed and import them. In this case, I commented out these 2 lines because Google Colab offers us an environment that has already different popular Python libraries available. For example, in this first chapter, I am using requests and pandas. The first is to perform HTTP requests in a human-friendly way, as they say by the documentation. And pandas is instead the arguably most popular library in Python for data elaboration. So these in this Google Colab environment are already available. So I'll just need to import them. Let's start executing the code. As you can see, we are being connected to a machine offered by Google. Here we are. And the libraries have been imported. So the first thing I am doing is I want to know from Python all the datasets that I can use from Ocean Eyes ERDDAP. This is exactly what I was showing you here. I want to query this dataset. I'll do this with a very simple query. So by calling the base URL, calling the old dataset, specifying the format CSV, and you will see this a lot today. And then passing after the question mark the queries, the variables that I want to gather. Yeah, I said CSV will come a lot today because it's perfect for integration with Pandas library I was talking before. Pandas has a basic structure that is the Pandas data frame that is exactly a table. So as you can see, we can start performing a request. And with this simple method of Pandas, we can import the response from the server kept in memory directly into a Pandas data frame. So we have a table that is now being populated. I perform here a little bit of data cleaning, just removing empty rows if there are. This is a good practice. And then by calling the name of the variable at the end of the code cell, we will see the output. So as you can see, this is exactly what we have seen from the browser. I filtered only the fields, the columns that I need. So the name of the dataset in the first column and the URL. That is what we need for Python to access the data. By following the next section, I am starting to work on a single dataset, chosen arbitrarily by example. And we want to have a picture from Python code of this dataset. We want to know first what variables do we have available, so we can later filter the data. So we'll substitute this table DAP, that is a kind of dataset that is on ERDDAP, with info. And again, I'm requesting for a CSV format, comma separated values. So we are importing now. So you can see it's also very fast. And we have here a list of all the variables that are available in this dataset with their data type. We can now start to get a little bit more practical. So we want to interact from Python with ERDDAP to get the data, so we can then use it as we see fit. So I declared the base URL in a code cell before, is the base URL of the Oceanize ERDDAP. And now I'm just starting to add different kind of queries. So again, the format is comma separated values. Then we start the query by requesting the variable we want to gather. In this case, I want to know just what platforms I have available. And this is a server-side function. It's a service that offers ERDDAP. It just means we want to get the unique rows. I don't want any duplicates. So we can execute also this cell. And as you can see, these are the platforms that we have available. I'll just show you what's happening also from ERDDAP. So the dataset we are using is this one. These are all the variables we have seen from the Jupyter Notebook. And as you can see, these are the platforms that we have received. So we know that everything worked well. Here we have the server-side functions part. So I check the distinct. And ERDDAP gives us a very beautiful feature. So we can start to query. I don't know, we want to get the platform codes, the time values. And in this section here, we can choose our format. As you can see, there is a big list. For example, what I have chosen from the notebook is CSV file. And by pressing just generate the URL, we get exactly what I have built manually here. So for the first attempts to interact with ERDDAP, this is a good way to create the good queries. Once we have the list of platform codes for this example, I start to apply some filters to the data. I show you directly from the Python code. So we are declaring, this is the platform we want to filter, to gather. And this, you may already be familiar with this. We specify the format, start with the question mark, the query, and then pass a list of variables that we want, separated by this percentage to see. Might look scary, but it's actually just a comma in HTML encoded. So it's like we effectively are telling her that we want to platform code and time and latitude, etc. After declaring the variables we want to get, we can specify some filters to apply on these variables. So I want my platform code to be exactly equal to this one. And again, here there is a HTML encoded character that is a quotation mark. That's because the platform code is a string. After this, with another and, we can apply an additional filter that is, I want my time values to be between this date here and this date here. So greater than this and lesser than this. Let's start executing this cell. As you can see now, we actually have the data. So we have our platform code and confirm it's what we asked for. Then the time values that are automatically sorted in ascending order, our coordinates, and our temperature values. You might see I requested for data from April 2023 to April 2024. This is arbitrary. But we only got from January to February 2024. That's because this is all that's available for this specific platform. Of course, this is at the basic of just how to build the queries and to send the request to ERDDAP. In these following sections, I went a little bit more in depth, but I won't waste any more time on this. The basic concepts are the one you have seen before, but then can be combined to apply some a little bit more complex filters. So we can ask for multiple platform codes and filter by coordinates and so on. This is all for the first chapter, and this was very introductory. In the time remaining, I'll give you a brief overview of what can be done now with the data that we have gathered. So let's start, for example, by this. You can open the collab. As you can see, we have our introduction. So whoever accesses the Jupyter Notebooks knows what is the objective, the scope of the notebook, some information. And in this case here, I created, I chose to hide the code because the main scope was just to present the analysis that has been done on the data. We have also added some filters so we can give the user the chance to create the filters to apply to the data without having to write the code. So we can insert inputs, just textual inputs like this. And I'll just show you what we can also create some drop-downs. Maybe let the user choose what parameters he wants to get. And another option we have is also to work with HTML. So in this example here, this dataset is working with data that has been taken from sensors, from seals. So I'll just show you briefly for clarity the code, what is happening, but it's a bit long to explain. Anyway, we are getting the data for all the platforms, so for all the seals. And then we are creating an HTML animation with the values of temperature closer to the surface. So we have what we obtain is a trajectory map in time. Okay, we can see here the time. And can you still see me?
Yes, no, yes.
Okay, perfect. But it was frozen. And as you can see, we have the observations colored accordingly to the seawater temperature. So we can see the trajectory and have an additional information of the temperature. After this, I've done the same with the pressure. So these are photographs in depth instead of in time. The axis in this case is depth. This was just one of the examples. And from the website here, you can access all the collabs for all the other Jupyter notebooks. And I guess for now, it's all I had. In the time I had, I wanted to give just a brief overview of what is possible to do by working with Jupyter Notebooks, Python code, and interact with oceanized data from ERDDAP. Then we will share some links to the participants for who wants to get more information about ERDDAP or Jupyter Notebooks format and the Google Colab environment.